Our international research team is developing a way to use technology and intuitive user interface to be able to identify and map species of triatomine insects, which are a vector for Chagas disease.
We're here in the state of Yucatán in Tikul, which has a very high rate of infections with Trypanosoma cruzi, so that we can standardize better tests for the infection and better tests for clinical disease, for Chagas disease. Chagas is a disease which is chronic. That means that from the time of the infection to the time of the onset of symptoms, 5 to 20 years can occur. Primary symptoms of the disease are for the heart and secondarily to the intestinal tract. 40 to 60% of the persons who actually receive the parasite will develop these types of symptoms, which in the end are lethal. There are multiple modes of transmission of the parasite which causes the disease. One of them is fetal transmission, blood transfusion, oral transmission by eating contaminated foodstuffs or drinks, but the primary is the vector transmission by an insect vector called triatomines.
Triatomines are blood-sucking insects. They are vectors of Chagas disease, and there are about 150 species around the world, mainly in the Americas. Triatomines feed on mammals. Most mammal species in the Americas are infected with Trypanosoma cruzi that cause Chagas disease. So, frequently, bugs are infected with this parasite. Infected triatomines feed on humans and defecate the parasite in the skin. And the parasite enters in bloodstream by abrasions or mucous membrane. Some species are better carriers than others. That's why it's important to analyze the geographical distribution of Chagas disease vectors.
Me gustaría de saber si conoce este insecto acá. ¿Sí?
Sí, sí.
¿Cuál es su nombre?
Pic.
¿Pic?
Ajá, pic.
Sí.
Y aquí pescamos 20, 30, una noche.
¿En una noche?
Una noche.
¿Sí?
Sí.
¿Dentro de casa?
Ah, sí, sí.
¿Y de dónde les vienen?
Pues allá que y ahora que salimos a sentar acá, solito viene, es de volar. Ajá.
¿Volando?
Así viene.
Uf, en la
sí.
pared.
Además viene de caminar de la tierra.
Ah, sí, caminando,
Ajá.
por ahí.
Ajá, aparte que viene de volar.
Sí. Pero ellos vienen de la floresta.
Ajá, sí, cualquiera donde esté este sitio. Sí, hay más. Ahí está uno. A veces fumiga en mi casa.
¿Ah, sí?
Sí.
Ahí está.
Un baico.
Adulto de triatoma de imediata. Ahí está, pero ya está muerto
Sí.
debido a fumigación.
Sí, fumigación.
Sí.
Todo alrededor.
In Mexico, we have between 1 and 2 million persons infected with Trypanosoma cruzi today. Once we know that people have the infection with Trypanosoma cruzi, even though they may not have clinical symptoms of Chagas disease, we can recommend that they be treated, and the earliest that they get the treatment, the better and the greater chance that they will not actually develop the chronic symptomatic disease, which is principally cardiac. Triatomines are everywhere in the landscape, and we're never going to eliminate them. So the only way we could prevent contact of the triatomines with the humans is for the population to be aware of their existence, of their danger, and that they can recognize them, and that they could differentiate them between other insects in their environment.
Triatomines can live in and around houses. They can invade homes and feed on domestic animals, and they can be found in chicken coops, in kennels, and in barns. Triatomines can be found in rural or urban areas. In the last years, some areas, urban areas in Brazil, Mexico, and others in Latin America, we collected a lot of triatomines in houses.
in the midst of good prevention programs, if you could give the population a tool whereby insects that they find in their vicinity or that come in contact with them, if they could take a photograph, upload it, and then both the healthcare system and others are informed about the presence, then that should immediately motivate a reaction by the healthcare system so that they can come in and help the population take a look at what other strategies are required to get rid of the triatomines in the houses or in the areas surrounding their houses.
Virtual Vector Lab is a project designed to solve a single problem in this broader challenge of Chagas disease and avoiding more human misery caused by it. One big problem is that of identifying the insect. So the reason why we want to provide identifications or obtain identifications for these bugs is that different species of triatomine bugs have different characteristics about how they do or do not transmit Chagas disease efficiently. One species may be a very aggressive biter, another species may live in houses only or live only out in the trees or in the rocks around the houses. And each different species with its different natural history will have different characteristics about how it's going to transmit the disease, but also how the disease transmission can be combated. So it's very important to get precise information about which species is present in an area. And that's an ability that the Virtual Vector Lab can speak to by essentially building broad, universal, open access identification abilities. The whole idea of the Virtual Vector Lab is to work with the people who actually can identify the insects by hand and use their expertise, translate their expertise into automated facilities that essentially work from photographs of the insects to create high quality, precise identifications.
Ese pues ya es el pic número 29 que encuentro en mi casa. Por suerte, de los 29 que encontré en los pocos meses que vivo acá, 28 los encontré afuera, como este, y solamente uno adentro. Pues sí, a veces entran, ¿no? Pero entonces pueden entender realmente por qué, o sea, si no tuviera los mosquiteros, que pues los pics que he encontrado afuera los hubiera encontrado adentro, ¿no? Como ese que encontramos una vez, no sé cómo entró, yo creo que por la ropa se quedó colgado y lo metimos nosotros y lastimosamente nos picó. Pero bueno, se pueden dar cuenta la importancia de tener barreras físicas. Pero algo que quiero recalcar es que ayer les decía que eso era la mejor opción para protegerse del pic, pero eso es cierto aquí en Yucatán, donde ese insecto vive en el monte y entra a las casas volando. Son casi puros adultos todos los que encontramos, pero no colonizan las casas, no encontramos colonias, ¿no? Pero en otras zonas, por ejemplo, Triatoma infestans en Sudamérica o Triatoma dimidiata, en otras zonas de Centroamérica, sí coloniza, ¿no? Entonces, en estos casos, pues quizás el uso racional, ¿no?, de insecticidas.
In the US, we have extension services, which are usually funded by the national or the state government to provide identification expertise, let's say, for farmers. So at the level of the Americas and for Chagas disease, that extension service, that identification ability really comes to depend on a small number of experts at a small number of institutions across the region. The Virtual Vector Laboratory speaks to this need for entomological expertise. The need is growing. The breadth and the universality of the problem of trypanosome infections, Chagas disease, the appreciation of how broad that is has gotten big, very big.
One of the biggest problems with surveillance of a lot of these diseases is that they're not recognized early enough by healthcare workers. And there's virtually no tools in the hands of the population to maintain that surveillance. The parasite that causes Chagas disease is a parasite that is principally transmitted by the insect vector. If it occurs via the insect vector, then the parasite contaminates the person. 5 to 20 years can go by where the person has no symptoms whatsoever. And so there's no perception of disease. They do not seek medical attention.
Ustedes conocen estos insectos acá, como este o como este acá.
Sí, lo conocemos, sí lo conocemos.
¿Sí?
Sí, es conocido, lo ven. El pic comercial.
El nombre es pic.
El pic.
Sí. ¿Y cuándo fue la última vez que vio este insecto?
Ayer.
¿Ayer? Este insecto, ¿es posible que alguna enfermedad está asociada a este insecto?
No, nosotros no sabemos que se infecta y todo. O sea, ya que nos pique, le ponemos lo que dice usted.
¿Sabes si alguien de la comunidad pasa en las casas preguntando sobre estos insectos?
No, nadie.
¿Alguien de la salud?
No.
Sí, fumigan por los
Por
moscos.
los moscos que hay un chorro.
Solo por eso.
¿Ellos fumigan?
Fumigan por los moscos.
¿Las casas?
Sí.
No.
Ah,
Pasan
por
de,
las
de las
moscas.
calles, de las calles.
Moscos, hay muchos moscos, te pican los moscos.
Pero no por causa de esto.
No,
No, por más por moscos, no por moscos.
Some of the primary symptoms, for instance, with some of the vectors, which provoke a dermal reaction, is a key point that we can use and try and train the population that if you have this type of dermal presentation, you should all automatically go to a health clinic, and if the health personnel recognize the dermal presentation, what we call the chinchoma, as being related to the bite of a triatomine, then automatically the health personnel will say, come back in 4 weeks so we can take your blood sample and we can diagnose you.
La primera pregunta es que, ¿conoce este insecto?
Sí, ese insecto se llama lo que es el pic, un bicho que te pesca la piel, te absorbe la sangre y deja una pequeña infección. De hecho, mayormente se alimenta de pura sangre, o sea, de lo que son los bichos, o sea, en su mayoría personas, ¿no?
Sí.
Es un bicho que existe, que se esparce en plagas. Cuando tenemos lo que es constante calor o constante lluvia, porque como ellos se guardan a través de lo que son rocas o techos de casa, pues obviamente sí podemos encontrar ese tipo de insecto bajo un mueble al techo de pared, o un lado del sofá o un lado de la hamaca. Es el pic.
Ok. ¿Y sabes decir si hay alguna enfermedad que estos pics pueden transmitir? ¿Ellos son peligrosos?
Infección en la piel. Infección en la piel, ronchas, sí te puede transmitir. Porque como son insectos que se van en diferentes terrenos húmedos o lo que es, por ejemplo, en donde hay mucha hierba, pues ellos se alimentan de diferentes insectos. Entonces ellos al picarte te transmiten esa pequeña infección. Sí. Entonces pues sientes una roncha grande acá y tienes que como que te duele algo. Entonces son esos animales que te pican y te absorben la sangre.
So when we decided to take on the challenge of automating identification of triatomines, then the question was, whom do we need on the team? So we definitely needed biologists. We definitely needed people to think about the computing challenges, and we definitely needed some people to think about form and image and capturing all of that information. And so that kind of gives us the basic outline of the team. At the University of Kansas, it's the Biodiversity Institute, the Spencer Art Museum, and it's called ITTC, it's the Telecommunications and Computing Institute.
We do better work when we bring in specialization from different areas. As a computer scientist, can I say, oh, you know, you probably have some difficulty with your eye visually distinguish the amount of variation in color between these two areas. That's easy for me, so why don't I collect a bunch of what I would call photometric data Those things I can find easily. I'll see what they do. And then I could throw those in as metrics. And so I've then spent a great deal of time going back and forth, trying to find the best set of characteristics that will allow us to distinguish among the species. So I've got a photograph. I don't have a bug. What I've got are just an incredible number, probably 4 or 5 million numbers. That is, a light intensity from each one of these adjacent pixels. From that information, I can bundle up these pixels in different ways, and it's really easy for me to run statistics on these. Mean, average, standard deviation, wow, okay. You can give it billions of points and it's happy to get those numbers for you. And those are things which quantitatively our eyes do not do so well. And so that's what I've been looking all along is, hey, how do I combine, again, different sources of information to solve a common problem?
One thing that Jarrett did as part of the project almost immediately was to notice the poor quality of the images that we were using to decide which species is which. And so he designed a portable, very rugged, field-ready photo stand that allows us to capture consistent, high-quality imagery and essentially jump over a whole suite of problems that otherwise would have complicated our processing of the images. So this photo stand can be taken into the field, it can be used under a whole set of different light conditions. It can upload the photographs very quickly via the internet and deposit the photographs into a central stash that the remainder of the team can access in essentially real time.
Please do.
This is a wonderful example of applied research. I much prefer to work on applied research than research. Much of the work here at our lab, fortunately, really has been applied research. We actually build things. We deliver them and show how they work. This really could be helping people identify bugs in the field, and very soon. I think the prototype has demonstrated that we can solve this hard problem, but we haven't solved it. We've demonstrated capabilities. I'd really like to see this become truly applied research and get out into the field.
So where we are right now is that we have a complete working prototype, which is to say one can take a photograph of a mystery triatomine, one submits that photograph to EdComp's algorithms for processing images, the image gets cleaned up, compared to the reference series of images, and identified. It works, and it works at better than 90% efficiency now. So where we'd like to be in a few years is imagine any person in any village across the Americas could have an app on a cell phone, and that app guides them through taking a picture that's high enough quality that our identification routines are able to identify the species of the triatomine that's interesting to this person with a pretty high degree of confidence.
To fight global diseases, we need global teams. I see the end result of the virtual vector laboratory being a new way to connect grassroots patient advocacy groups, healthcare workers, researchers, and politicians, and bring them all together at the table in the common goal of fighting Chagas disease.